So what will be the derivative of a constant? For that I am just taking the function to be, suppose a, which is a constant. Okay. So we are just applying the first derivative test, that is f dash of x will be equal to limit h tends to 0 f of x plus h minus f of x by h, by definition, right? Now if f of x is a, it is not having any x term. That means if I write f of x plus h, then also the value will not change, it will be a again, right? So if I am substituting here in place of f of x plus h, I have to substitute a only, minus what is f of x, again a, by h. So what you are getting is 0 by h, and since the numerator is 0, you will write 0. Okay, so the derivative of a constant, d by dx of a constant is nothing but 0. Okay, derivative of a constant is 0. Now while talking about what is the derivative of a constant into a function of x, that is d by dx of a constant into a function of x, whatever be it, we can take out that constant as we do in limits. Okay, lambda into the derivative of the function. Because we are differentiating it with respect to x, we will differentiate the function of x with respect to x, and that constant will be taken out if it is a product of these things. But if the constant is alone and you have to take the derivative, then the value will be 0. That doesn't mean that here you have to write this, its value is 0. So lambda can be taken out if you have a product of two things in which one is a constant and one is a function of x, and then differentiate the part which contains the x term. Understood? Okay, so I'm just showing you an example. Suppose I have to take the derivative of 2x cube. So here 2 is a constant. In place of lambda I have taken 2, and in place of the function of x I have taken x cube. So what I will do is I can take out 2 and then differentiate x cube with respect to x, so that I will get 2 into, what was the definition of derivative of x raised to n? That we will apply here. So instead of n you have 3, so you will get 2 into 3 into x raised to 3 minus 1. N into x raised to n minus 1. So here you will get 6x square as the derivative of 2x cube. Clear? So in derivative of polynomials, first we are starting with that it is actually given as a theorem. Okay, we are taking a polynomial f of x in a general form. That is, general form of a polynomial is a n x raised to n plus a n minus 1. The suffix, this is n, and the power of x will also have the same thing, and the power of x is decreasing, okay, till it becomes 0. So from n we are starting means it is of degree n. A n minus 1 x raised to n minus 1 plus a n minus 2 x raised to n minus 2 plus etc. plus a2 x square plus a1 x plus a naught. So suppose this is the polynomial given, polynomial function given for you, and we can say that what all you know about these things, ai's will be real numbers and an should not be equal to 0, then only we can say that it is a polynomial of degree n. If an is 0, you will not have this term, then it will become a term or a function or polynomial of degree n minus 1. That's why we are saying an is not equal to 0. Okay. Now we have to find out the derivative of this function. For that what we will do, again notation for the derivative can be either f dash of x, or you can use df by dx, or you can use df of x by dx. Any of the notations you can use here. Now again you have a, in between you have plus sign. That means derivative of this whole term a n x raised to n plus a n minus 1 x raised to n minus 1 plus etc. a1x plus a naught will be same as separately taking the derivative. So you'll get d by dx of a n x raised to n plus d by dx of a n minus 1 x raised to n minus 1 plus d by dx of, I'm actually writing in terms of this, okay, I have not written here all the terms, a n minus 2 x raised to n minus 2 plus etc. plus d by dx of a2 x square plus d by dx of a1x plus d by dx of a naught. Now, according to what we have discussed earlier is, you can take out an is a constant. It is a real number, means it is a constant. So, an can be taken out from the derivative. So, this is an into derivative of x raised to n. Plus, again an minus 1 can be taken out. Then it becomes an minus 1 into d by dx of x raised to n minus 1. Plus, an minus 2 d by dx of x raised to n minus 2 plus etc. a2 can be taken out, and d by dx of x square it will become plus a1 taken out, d by dx of x plus d by dx of a naught. Again, derivative of a constant is 0. So here you can write 0, because already we have discussed derivative of a constant is 0. Now what happens to this? It will become an, which is a constant, as such written. Now the derivative of x raised to n is n x raised to n minus 1 plus an minus 1 derivative of x raised to n minus 1. Again you are applying the same thing, that is d by dx of x raised to n is n x raised to n minus 1. This is what we are applying here also. So instead of n you have n minus 1. So you will have n minus 1 into x raised to n minus 1 minus 1. So it will give you x raised to n minus 1 minus 1 will give you x raised to n minus 2. So it is n minus 2 plus n minus 2 derivative of this will give you n minus 2 into x raised to n minus 2 minus 1. So it is x raised to n minus 3 plus etc. This term will become a2 into derivative of x square 2x plus a1 into derivative of x 1 plus 0. So at last we are getting an. Since these two are constants, we are just writing an into x raised to n minus 1 plus n minus 1 an minus 1 x raised to n minus 2 plus n minus 2 into an minus 2 into x raised to n minus 3 plus etc. plus 2a2x plus a1. This will be the derivative of any polynomial of degree n. What will be the derivative of the trigonometric function sin x? For that we will use the first principle of derivative, okay? And what is that? F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, right? Now if f of x is sin x, what will be f of x plus h? It will be sin of, wherever you have x, you have to replace it with x plus h, okay? So limit h tends to 0, instead of f of x plus h, you will have sin of x plus h minus sin x whole divided by h. Now this is a formula which is sin c minus sin d. You know what it is? 2, if it is subtraction, you will have first cos, 2 cos c plus d by 2 sin c minus d by 2. That is what we are applying here. So this is your c, this is your d. Apply and what you will get? Limit h tends to 0. First you will have 2 cos, the angle will become this plus this by 2. This is x plus h plus x by 2 will give you 2x plus h by 2. So the angle becomes 2x plus h by 2 into sin c minus d by 2. C minus d means x plus h minus x by 2. So that you will get h by 2 here. Okay, so the second angle becomes sin of h by 2 whole divided by h, which is equal to limit h tends to 0. Now if you want, you can take this 2 out also. And one more thing which you should remember is you have product of two functions and the limit can be given to 2 separately. That means I am just giving like this, 2 cos of 2x plus h by 2 into limit h tends to 0. Now again, one thing we should remember is here you have the angle of sine is h by 2 and we have a result that limit h tends to 0, sin h by h will be 1. If I am writing x here, all should be x. So this is a property of the limit, and this property we will use here. So if I can use this 2, here it is 2, I am just using this 2 to write the denominator as sine, because already I have a h, one h that I am taking to this part, because it is a product, you can use only once. So it is h, and this 2 is taken to the denominator of h, which will be same as in the numerator. So it will become like this. Now since h is tending to 0, h by 2 is also tending to 0, and this is satisfied. Whatever angle you have, that is in the denominator. That means the value of this will become 1. So you have limit h tends to 0 cos of 2x plus h by 2 into 1. Now you can give the limit, that is replacing h with 0, you will get cos of 2x plus 0 by 2, which is cos of 2x by 2 or cos x. Inside the angle you have this 2, so you can cancel. Okay. So the derivative of sin x is cos x. So for this we will just replace f of x plus h as tan of x plus h minus tan x divided by h. Now tan will be replaced as sin by cos. Tan x is sin x by cos x. So we are just replacing here with sin and cos, so that this becomes sin of x plus h by cos of x plus h minus sin x by cos x whole divided by h. So this will become limit h tends to 0, 1 by h into, because I need to take the LCM, I have taken h out. What will happen here? In the denominator you will get cos x into cos of x plus h, right? And in the numerator it will become sin of x plus h cos x minus sin x into cos of x plus h. Now what is the numerator? It is sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is equal to sin of a minus b. So you can use here that formula, so that the numerator becomes sin of, what you will get here, instead of a you have x plus h, and instead of b you have x here, so that you are getting here sin h, right? Sin of, you understood this, sin of x plus h minus x divided by cos x into cos of x plus h is equal to limit h tends to 0, 1 by h into, numerator will become sin h divided by cos x into cos of x plus h. Now we will take this h together with sin, so that we can use the limit identity, which is equal to limit h tends to 0 sin h by h into, again for the denominator separately we can give 1 by limit h tends to 0 cos x into cos of x plus h. Now here we can apply the property, so that this will give you 1, and in this one if you replace h with 0, what you will get is 1 into 1 by cos x into cos of x plus 0, which is again cos x. So it is 1 by cos square x, which is sec square x. So the derivative of tan x is sec square x. If you have the question as f of x equal to sin square x, you can write this as sin x into sin x. What is the Leibniz rule or product rule? uv the whole dash is equal to u dash v plus v dash u. That's what we are applying here. You have two functions u and v as sin x and sin x. So f dash of x will be, u dash means what? The derivative of first function. So d by dx of sin x, which we have already studied, into sin x plus, again the second function is also sin x. So it is d by dx of sin x into sin x. What is the derivative of sin x? Cos x into sin x plus derivative of sin x, again cos x into sin x cos x sin x plus cos x sin x will give you 2 cos x sin x, or you can write 2 sin x cos x as sin 2x. So the derivative of sin square x using Lebanese rule, you will get the answer for any way, you will get the same thing, but this is using the Lebanese rule or the product rule. Okay, using product rule. Now I'll tell you one more way to find out the same thing. That is, if I am considering the given function f of x equal to sin square x as sin x the whole square. So it is just like x square. So what you will do for the derivative of x square, you will write nx raised to n minus 1. So here you will have 2x raised to 2 minus 1, right? So it is 2x. Likewise, when we do this, if it is not x, you have to again take the derivative of what is the original function mentioned here. So if I am treating it as, this is some x, so it is x square, means you will write 2 into sin x the whole raised to 2 minus 1. So you will get sin x only. But since it is not x, we are just differentiating or writing the derivative of that term which is instead of x, and that is sin x. Okay, so this is actually a chain rule. That also will give you the same answer. That's what I'm showing here. So this will give you 2 sin x, and here the derivative of sin x is cos x. So see, you have reached this point in one step. But the thing is, you should remember that you should take the derivative of whatever function you have instead of that x. So this will give you sin 2x. So both have the same answer.